Ladies and gentlemen, please welcome Senior Vice President, Security Products, VMware, Tom Korn.
Terrific, thank you. Welcome, everybody. Thank you so much for coming to our security keynote. We have a really special program planned for you today. Over the next hour, I'm going to spend a bit of time just outlining what's our vision for security and where are we headed in this domain of security. As you heard from Pat's keynote on the first day of VMworld, this is a really increasingly big focus for us. But I'm going to switch gears in the second half of this presentation. What started as a dare about 2 years ago, and every year this escalated, we've been doing a live attack and live defense. It's actually the only one of its kind that we ever do at VMworld, because no one else is insane enough to do this. There's no safety net here. We actually have an orchestra pit in some of these rows where we have some of the DevOps teams that are monitoring what's going on in a data center in Santa Clara. But we're actually going to do to really give people a feel both for how these attacks happen, as well as why some of these techniques to defend work. But let me maybe dive in and pick up where Pat Gelsinger left off on the day one keynote, which is the statement that there's something fundamentally broken about a traditional security model, and that I guess the best way of describing it is fundamentally reactive. We tend to build infrastructure somewhat generically, not knowing what kinds of applications we're necessarily going to have run on top of it. It leads to a lot of flat networks, open design the infrastructure more as a utility. We layer on top of that a variety of applications. Those applications change on a pretty regular basis, arguably at an increasingly rapid basis. And then we tell the security team, go secure this. It's really an impossible task to come in at the end and try to bolt something on, not to mention the fact that they're trying to deal with not only incredible numbers of different types of attacks, but those numbers change, by the thousands every day. And as what happens is, of course, the costs of security go up, costs not just in the equipment, but in complexity. The average organization owns probably around 50 of the products that you see on this chart. And so the costs of security have continuing to grow significantly faster than IT overall. In fact, looking over the last several years, growth in security spend has been a little over 10%, whereas growth in IT overall has only been about 4 to 5%. Now the question is all of this been effective? But this chart here is actually a 2-scale model of just the breaches that have happened over the last couple of years. Right? We see the cost of breaches really being the only thing that's outpacing in growth, not just in size, but in growth, the pace of investment in security. Right? A model like this, it has to stop somewhere. You cannot incrementally improve this model. It's a runaway system. In fact, the only arguably thing we can start to do on something like this is to fundamentally change the game, to transform. Now, part of the reason this is so difficult stems from the fact that security is fundamentally an asymmetric battle, right? Defense is always harder than offense. They throw 1,000 arrows at you, you have to stop every one, they only have to land one. So how do you transform an asymmetric battle? Well, it starts by, when you're vastly outnumbered, right, ceasing to just fight in an open field. Right, that is not a winning move. We need to change the battlefield. Right? Arguably, we need to be able to fight in a much more constrained environment where the numbers of our attackers perhaps are not as meaningful as they would be in an open field. That's how you defend a homeland. Maybe let's bring it closer to home and think about how you protect your own home. Right? If someone were to sneak into my house in the middle of the night, they're going to find a few things. So first of all, if they do manage to find an open window or break into some part of the house, well, first of all, they're going to find that I've locked the perimeter of the house. They're going to find that inside the house, most of my doors are closed. They're going to find that the lights are off. My son's skateboard is precariously hidden somewhere in the hallway, although I'm much more likely to find it myself. certain rooms are locked. For me, it's the door to the garage, the door to the backyard. And if they are able to somehow enter into this house, I know my house. They don't know my house. They don't know how I use my house. And a noise in the playroom or in the study or in the living room at 2 in the morning, to me, immediately means there's something not right. I don't use my house this way at this time. This is what gives us some advantage. Knowing how my family uses my house puts me in a position to have a sort of a form of home court advantage. This notion that an advantage that I have over an opponent by virtue of I know my playing field and I can have them operate on my own field. The question, I suppose, is why don't we take advantage? This may be the single advantage defenders have over attackers. And when you look at how we use our data centers, the family is the application, and the house is what part of the infrastructure the application uses. In our house, every light is on, every door is open. We actually don't know how our family uses our house or how our applications use our infrastructure. So these aren't playrooms or bedrooms or kitchens. These are rooms, generic rooms of different capacities and sizes. And in fact, we don't even lock the perimeter of our house. We don't even think of terms of our house. We think in terms of the city this house is in. We think of roads. We think of rooms. These are our perimeter, our network, our endpoints. And most of our investment in innovation is going and trying to find what bad things look like, right? Looking for attacks, for threats on my perimeter, on my network, on my endpoint. We are fundamentally seeing things through the lens of the infrastructure, and most of our innovation as an industry and investment is going to get better and better at finding attacks. And candidly, there's been proportionately much less investment in innovation in reducing attack surface. It's backwards. One of my favorite frameworks right now was the following, developed by Neil MacDonald at Gartner. Actually, we're privileged to have Neil here in the front row. Neil, welcome. Neil laid out what I think is a very insightful framework that basically says this is all an exercise in risk management. There are a set of things that you can do to protect a workload, and if you stack rank them by how much risk does it really get rid of, what you find is, what are the things that get rid of big risks? Patching, configuration, segmentation, system integrity, locking down applications, encryption. Running AV on a Linux server inside the data center really addresses very marginal risk. And if security is a risk management exercise, really the task that we have is, are we investing whatever money we're going to invest on the things that will have the most material impact on risk? So in our perspective, we have to shift more of our investment proportionately into how do we reduce the attack surface. And then secondly, we have to shift from looking purely at infrastructure to looking at applications and data, to understanding how our family use our homes. Here's the argument against everything I just said. I don't understand my applications. I got thousands of them. I don't even know my applications, let alone how my applications use my infrastructure. And here's where I think we're at a point in history where we have a unique opportunity to really change the tide. And that is because, and where I think VMware has a potentially huge role to play here, because we possess and you run layers of software infrastructure, both in the data center and on your endpoints that you're already using for other reasons, that happen to be abstraction layers sitting in between the actual infrastructure and the applications and data that are running on top of it. And in a nutshell, our strategy and vision is to leverage our position, both in the data center and on the user endpoint, to bring far greater clarity and understanding to the applications and data that are running on top of it, and then to be able to leverage the infrastructure to lock it down, to create least privilege environments, to compartmentalize, to encrypt, to create zero trust environments. That can get rid of enormous quantities of attack surface. Now, there's always residual risks components. It's not about question about finding attacks goes away. And in fact, I think in a strategy like this, we can also add enormous value to the players that are doing just that. And so with solutions like App Defense on the compute side, or NSX at the network side, or Workspace ONE on the user side, part of the strategy is also how we work with an ecosystem of strategic partners where we can help them both in getting better context from the infrastructure and to be able to use the infrastructure itself as an enforcement point. Without agents, without boxes, without other elements that are bolted on. Use the infrastructure in order to do that. So this is, in a nutshell, really our vision and strategy on security. And I think it's helpful to then bring it to each of those pieces and understand what that specifically means. And I'll start with compute and with App Defense. Pat actually spoke a lot about this in his keynote. The idea behind App Defense is actually quite simple, right? What if you had something that you could turn on that would show you what each of your VMs are for? It said for each VM, this is its purpose, this is part of the web tier of this application, its composition, and its intended behaviors. And then what if you could say, I want the hypervisor to lock what's running against that? It would really shut down enormous amounts of attack surface. And so what we've done in order to do that is leverage the inherent uniqueness of the hypervisor. Because it's something that you already run that has unique visibility both into what's running, but also what you provision to run there in the first place. It's in a unique position to do this without agents and in a way that can't be shut off by an attacker who has root or shell access to the machine. It's in a unique position to automate any sort of kind of response mechanism, whether it's snapshot the VM or block the communication or suspend the machine or re-image it. So it really is in a unique position to do just these things. So what we did is built a component to learn what things are supposed to be and a component that enables you to lock it to that. Specifically, on the learn side, what we did is we hooked into vCenter, which actually has a really good inventory of the machines, and that activates our position in the hypervisor to start looking at what's running and what's installed on those machines. Now, that will include off-the-shelf software, custom applications. We're seeing processes, how those processes are triggered, how they communicate. And we use a few methods to make sense of this. For off-the-shelf software, we have these enormous feeds, some we've built, some we've licensed to understand how to map a process running in memory to, yeah, that's part of Windows 2012 R2, or this is part of this Linux distribution. We did a very interesting technique for customized applications, which is that we integrated into the CI/CD pipeline. Puppet, Chef, Ansible, Maven, Jenkins, these are tools your application teams are using to make it more efficient and less error-prone to roll out applications, and they happen to have incredible authoritative context about what things were supposed to be, and we use that. But the third element, which has really been a huge boon for us, is we built a really meaningful machine learning team in the App Defense group to do two things, not to study malware. That machine learning group is studying goodware, machine learning models of how legitimate software functions and operates, and also to be able to do machine learning across all of our customers to say, you've got to fool one of us, you have to fool all of us. That is a very powerful model and gives us really the power to produce these manifests of what these machines are supposed to be and do. And that brings us over to the protect side, in which we've built the ability in the hypervisor to just monitor what's running against those manifests in a protected zone where you're not managing some new agent. And to use both compute and network virtualization to be able to have a variety of mechanisms to respond. All you're saying is, what do you want to have happen if what's running doesn't match what you intended to run? It's the ability to lock. But it's also the ability to adapt, right? In our new world, we don't change an application every year, we change it every week. And the beauty of this model is when you're patching, when you're updating, when you're modifying the application, our ability to say, hey, that's just a newer version of the same off-the-shelf software, or yeah, this came down from Puppet or Chef or Ansible, or hey, it's new to you, but I see this behavior on 1,000 other places where the same software and composition and setup are, allows us to immediately adapt. So that's really what we're doing on the compute side, and as Pat launched yesterday, we're incredibly excited. Today you can buy App Defense. We launched it last year. You can add it to vSphere, but we're incredibly excited about vSphere Platinum. vSphere Platinum takes App Defense, builds it right into vSphere. We actually built some new components right inside vCenter, and this, more than just being used by InfoSec teams, we built something that can now be used by virtualization teams that basically allow them to say, hey, this is what my VMs are all for. I want to lock them down so that that's a purpose-built VM. That's all it can do. And it will adapt, and I'll have a clear understanding what each of my VMs are for. Very simple, very powerful. Let's switch over to the network side. Now on the network side, the problem is that this application we're discussing, right, this family using this house, the different rooms inside this house, happen to be sitting in our environment commingled with thousands of other applications and tens of thousands of other machines. And the problem that we historically had inside our environments is a breach of anything was a breach of everything, right? Any segment that you had, if you had segments, you commingled components from different applications. And applications have to be able to talk to itself across different layers. So this did nothing to stop containing this. So about 5 years ago, we introduced this really novel approach called microsegmentation to say, hey, I can take a group of machines and compartmentalize them, and if there was a breach of something outside, it doesn't become a breach of this contained application. It was a very powerful concept, and that's actually spawned an industry at this point. You see other vendors doing microsegmentation. You see companies have microsegmentation projects at this point. But being the leader doesn't just mean being first. It means about innovating and setting the pace for where this is going. And we have been working on this for a while. And Pat introduced this yesterday. The next phase we think in the evolution of microsegmentation is adaptive microsegmentation. Segmentation that is aligned to the application itself and adapts as the application changes. The concept starts taking App Defense and NSX together and saying, look, if we're in a position using the hypervisor to tell you these are what those are for, because we can see the application, and what if we can use that to automatically generate the microsegment in a very granular, that's a perfect fit to that application. And if that thing could, if the application changes, automatically adapt the definition of that microsegment, and if we could lock the machines inside the microsegment down, now we have a much simpler operating model that not only stops these lateral attacks, but also stops a direct attack on the application itself. Not only that, it also helps starting to address the fact that you have machines in there that have to be able to talk to other stuff. Active Directory, domain controllers, DNS, patching server, all kinds of stuff. It has to be able to, it opens the door for us to be able to not only lock down those shared services, but how they interact. That's the opportunity here that we're calling adaptive microsegmentation. It's a big step forward, and it's really leading, I think, what's going to be the next generation of microsegmentation. And so we've introduced this concept, and this is going to allow folks that are looking at microsegmentation projects, network and security teams, to learn, lock, and adapt at a network and compute basis. It's going to make microsegmentation easier, much more aligned to the application, adapt as things change, really operate in what should be a DevSecOps approach to security. Now, the last thing I think in this picture is that user, that box of users over there on the side. Those users happen to have access, legitimate access into this application. And what if one of them or one of their devices is compromised? We To solve this, we need to know they are who they say they are. We need to know that I can trust the device that they're using. And we need to know that they legitimately have access to this. And these have been 3 silos of security. That leads to complexity. It also leads to something that's just an unpleasant environment for users, right? Certainly not a very transparent setup. The idea behind Workspace ONE is these shouldn't be silos. This should really be a singular policy or analytic to understand these 3 decisions. The interaction of these decisions should say, should I really get access to this? What do I need to improve in order to get access given the sensitivity of this? And the idea behind Workspace ONE Intelligence is to bring a level of analytics and data to be able to analyze this in real time and make decisions across this. Right? Focus on the application. Lock it down and enable this ecosystem of strategic partners, whether it's on the endpoint, the network, the MSSP front, to have benefit from this unique context and enforcement point. Let's take this and make it real. And this is where the Highwire acts. I'd like to invite up to the stage Chris Cord. Chris runs product management, product strategy, variety. He's my partner in crime. And today he is going to be our CEO of Chords.
Yeah, I'm honored.
Okay. All right. Thank you. So let's bring up Chris's screen. Can we take a look at Chris's monitor? So tell us about Chords.
Yeah, so Chords, we're a very successful e-commerce shop. We are about to get taken out by Amazon any day now, in the good way. We sell all kinds of cords, every kind of cord you can imagine.
Yeah.
We sell electrical cords, bungee cords, telephone cords, which is actually our best business.
Really?
Or not. People love telephone cords. I don't know why.
It's very retro.
It is very retro.
It's really hard to find your mobile phone unless you tie it down.
They really, yeah. A lot of people need them.
Okay. All right. So terrific. What's the kind of security setup you have on Chords?
Yeah, so we run a 3-tier application, pretty standard e-commerce application. We run at the front end of the application a load balancer. Behind the load balancer, we have an application service tier that's running Drupal to handle our application and web serving, and then we have a backend database running on MySQL. To secure that, we basically have standard firewalling at the perimeter of the data center. So clearly, we're going to firewall things that are coming in and out of the front end of the app, and then we also run standard AV on each one of our servers inside the environment.
Okay. All right. So terrific. Can we switch up to my slides for a second, please? All right. So this 3-tier app, as Chris was saying, as I said, Drupal. You have a load balancer web tier, MySQL, and you have endpoint security. We have a firewall at the perimeter. Looking at the dev, everything good? We're still running. So this is running in a data center live right now in Santa Clara, and now we are going to destroy it. For that, I would like to introduce from our own actual real security team, from our red team. If those of you are familiar, more sophisticated security teams will often build red teams. These guys are very skilled hackers. They hack for good reasons. But today our hacker is Prajwal from the red team of VMware. Prajwal, welcome.
By the way, I did bring the stormtroopers as reinforcements, just in case Prajwal gets a little bit out of line.
Good luck to you. Let's see how that works out for you. All right, so Prajwal, welcome. This is our second year of you being our hacker. Why don't we do this? Let's walk us through, maybe switch on to Prajwal's screen if we could. All right, so Prajwal, walk us through how you're going to destroy Chris.
Okay, Chris just mentioned that he's running a website on Drupal, so I'll do a little recon on it and see what version it's actually running and get some information there. And as you can see here...
So you're running like a Kali Linux box there, right?
Yes,
okay.
It's a Kali Linux, and you can see here that it's running Drupal 8, so...
Okay, so his app server has to be exposed, you have to be able to see it, and that's easy enough to see what it's running.
Yes. So I did a search on the search exploit, which is a local database of exploit DB where all the exploits are placed at.
Yep.
So I got a list of exploit codes here that have a exploit code for Drupal 8.
Okay, so this is legit. Right now, you could go out and you could get, these are legitimate exploits for Drupal 8.
Yes. So what we did is we got the shellcode modify it a little bit to get a shell on port 53, which is used by DNS, and get a reverse shell on the application server.
Okay.
And as you can see, I have a shell on the application server that Chris' website is hosted on.
Okay.
And
so now you actually have a position on that server. It's like you're there.
Yes.
Okay.
So the next thing I'm going to do is disable the endpoint protection on the application server to do more advanced stuff on it, which are usually restricted by the endpoint protection. So I'm going to run this script to disable the endpoint protection here.
Yeah, so this is an interesting point. There's a lot of very terrific endpoint security products. One of the challenges that they face is if you have a very often root and shell access onto that, it's very difficult to protect it from the same trust domain as the attack surface, right? Which is really what you're showing.
Right. So the next step I'm going to do is, since we disable the endpoint protection here, I'll run Mimikatz, which wouldn't have been possible with the endpoint protection on it. And what it's doing here is it's going to download the hashes of user credentials. So it ran, and I just typed the log here, and you can see that we have hashes for all the users here for different accounts.
All right, so Mimikatz is a known sort of utility used by red teams, also used by, and you're just basically mining credentials because you're going to need in order to move to the database, right?
Yes.
Yep.
So we have a hash for the admin account here. So what I'm going to do is I'm going to do a pass the hash attack onto all the systems that are within the network and reachable from the application server. So, and possibly have the same administrator account there with the same password.
Yep.
So what this will do is this will launch a Metasploit framework, and it will try to install a crypto miner on it.
All right, okay, terrific. So here's a way to make money, folks. You can install crypto miners on your favorite server farms at your websites of choice. And that's what you've done. Where are we in terms of still getting there, still going to execute?
And it's now compressing the crypto miner and uploading it to the database server.
Okay.
And we can actually see that. I can
see if it's running?
Yeah, the first thing, and you can see that the sysinfo points us to the database server.
Okay, so now you have position on the database.
Yep.
And you can run the commands.
And let's see. And there you go. We have a crypto
So we are now running a crypto miner on it. Could we switch to my slides for a moment? Okay, so just to recap what Prajwal just did. Prajwal is sitting on the outside. The website has to be open to traffic, so he's using a Kali Linux box to be able just to query to understand what it's running. He saw it was running Drupal 8. He essentially found a vulnerability that had some exploits. He opened it to be able to set up a reverse TCP connection to that app server, the Drupal 8 app server. At that point, he has shell access to that. So he dropped a shell, basically a PowerShell script that he turned off, deactivated the endpoint security, because it's going to be a nuisance to do the next move. And then he essentially mined sort of the hashes of credentials that are on there. So it's not like they were out in the open, but there's a technique called pass the hash that basically allows to pass that hash over and to be able to authenticate onto the next machine. At that point, he's basically got access to that database server, and that's where he essentially installed a crypto miner, and then we're exfiltrating Bitcoin on it. Very creative. Okay.
Thank you.
Chris, this is not good. This is not good.
Normally,
the future of Quartz is very uncertain now.
I'm not sure I can use that as part of my security operations center interview, because I just sat there and watched them do the whole thing. Yeah, I didn't stop a single thing.
That was all right. Can we switch on to Chris's screen, please?
Yeah, so obviously what he took advantage of is very much just open environments, right? It was a fertile environment for him to attack. There wasn't enough controls that were in place in order to us to stop him. He used open ports, port 53, port 80, port 443. These are common ports that are open in pretty much every environment, and our attackers are smart enough to take advantage of that, right? So what we want to start doing is layering in least privileged security into this environment. We want to start locking things down and controlling things as much as possible. In order for us to do that, though, we have to first start understanding and learning about the application. So what I'm going to do is I'm going to dive into our vSphere Platinum App Defense plugin. So what you're looking at is obviously the vCenter UI. So the first thing I want to do is actually go ahead and enable App Defense across a cluster of my environment. So if I just drop into the host and cluster screen here, I have a production cluster that includes 10 hosts, a bunch of virtual machines. And what I'm going to do is I'm just going to drop in to App Defense here. And you can see right here from the front page or the home page of this particular cluster, we could do a one-click and go enablement of App Defense across this entire cluster. So if you pop into the task list, you can now see that we're doing a bunch of installs and enablements of App Defense across that entire cluster. And again, because we can run this with all your standard VMware tooling and do it inside of VMware tools, this is pretty much all you need to do one-click and go enable of App Defense across the cluster.
Yeah.
Now, once that's done, obviously, App Defense will start collecting information and cataloging the data that we start to see from a behavioral perspective on everything where App Defense is running. So we already have another cluster that's already been set up with App Defense. So what I'm going to do is I'm going to dive into our dashboard for the App Defense plugin. And in the dashboard, you see a view directly inside of vCenter that basically starts to show you all of the processes, all of the behaviors that App Defense is vetting on your behalf. And again, all of that intelligence that you talked about in terms of how we aggregate data, how we understand data, how we view riskiness and the behavior in which those processes are executing, all of that is fed in right here. So we'll show you immediately all the processes that we vetted, if any of those processes exhibit any high risk. In this case, we vetted 28 processes across the installed environment. 19 of those have low risk, 8 of those have medium risk, and 1 we just weren't able to verify because it's probably a custom process.
Okay.
So you can dive into more detail, right? So all of this clicks through into additional detail. In this case, you can see every single process that's running in the environment directly in the vCenter plugin, if you'd like. I'm just going to highlight one process here, PHP/CGI. This is a common Drupal executable. I can see it's running on both my application tier servers, which is exactly what I wanted to do. I can dive into the app tier directly. And then that will show me all of the processes that are executing on the application server. I can look specifically into those things. And here I can see my PHP CGI, and I can see exactly what network activity is occurring for those particular processes for both inbound and outbound connection activity. And again, this is all directly embedded inside of vCenter, enabled with one click.
Got it. Okay. So can we click deeper into App Defense?
Right. So right from here, we can go direct into App Defense and actually get even further information. I already have a window up here just so you can, we can shortcut that login a little bit.
So this is the screen that Pat was showing yesterday.
Yeah, so what this is, it's a new feature. It's our application topology view. So this allows us actually to get a visualization of the environment, and specifically a application top-down view of the environment, right? So instead of what you see in vCenter is more of an infrastructure level up, this is more of an application level down. And in this case, what we're seeing is we have a 3-tier application, like I described before. We have our web tier, our app tier, our database tier. Again, these can be fed in and categorized by your CI/CD pipeline. I can see that my web tier has communication directly with the app tier. I can see that it's HA proxy communicating over port 80. I can see that the app tier has communication to the database. Again, here's our favorite process, PHP CGI, communicating over port 3306. All that's normal. That's standard for the MySQL port. I can also see external communication. So in this case, I can see that my app tier has some legitimate external communication that it's communicating to. These are public IPs, SVC hosts, which is a common offender in the Windows world for communicating in all kinds of interesting ways. It's doing a bunch of external activity, namely it's using port 53 to communicate externally. And again, these are the things that our attacker is taking advantage of. These are legitimate behaviors, but they are open ports that our attacker is trying to take advantage of.
And this is, I think, a really key point, right? You can't just firewall everything. The systems have to be able to communicate. They communicate to a lot of things that are not even part of the application. They communicate externally. So the visibility that's formed here is by doing introspection from the hypervisor to really understand both what's running and how it's communicating. You start to piece it together with information from provisioning, automation. You piece it together from information from the machine learning work that we're doing. And that's what allows us to have a simple picture. That user interface is the embodiment of seeing the infrastructure through the lens of the application. Now, of course, now you've got to validate that that's good stuff and not you just learned bad behavior, right? So walk us through that.
Yeah, so App Defense also obviously provides you all the details of all the activity as well as goes through a verification step. So this is the data-driven view of the App Defense UI. It's just an alternative view for anyone who's used it. This is mostly what everyone sees today. In this case, we're going to look at SVC hosts. And again, the important thing here is because it's very difficult to control an environment and set up least privilege policy if you have to manually create all these rules and understand if they're appropriate, which is the biggest thing. So in this case, we see SVC hosts, again, common Windows executable, doing all kinds of strange stuff, right? Communicating in all those different ways. What we've done is we've actually verified all of this behavior using the backend ML model. So basically what we do is we see this behavior for this particular binary, we compare it against the population of VMs that we have across VMware, and we can start to see that this is actually normal expected behavior for SVC host. It's above the line, don't worry about it, just verify and go, and the rest is taken care of for you.
Good, all right.
All right, so that's basically the learning process. That's where and how we learn the application and more importantly verify that the things that you're actually going to enable from a whitelisting perspective is appropriate. So that's the learning phase. Now what we want to do is start adjusting and moving this into protect phase.
Yeah.
So what I'm going to do is just quickly hop into NSX. So again, we want to both control the compute stack and the network stack using the same pieces of information. So I just want to show you the firewall rules to start. Get a live system. So in this case, we have no firewall rule set up.
Yep.
So we have a default NSX rule, any, allow, which is not very effective as a firewall. So I'm going to come into App Defense, and I'm just going to now go verify and protect. So this is basically taking all of the manifest details that we've learned, everything that we've verified, and it's now going to push these rules down to the compute manifests, and it's going to push the NSX firewall rules here. You can see this is the adaptive segmentation capability where we can actually push the NSX firewalling functionality. All right, so now we've essentially begun to push the compute rules down. So again, live system, it takes a minute or two for the compute rules to push down. Just popping into NSX again. I'm just going to refresh this screen. And now you should see a full firewall set of rules for this particular application. And again, the important thing is because we want firewalling and segmentation policy to be as granular as we can. And because we've learned everything about the app, we now have created specific granular segmentation policy here, right? So if I take a look at one example here, here's my app tier communicating to my database tier. If you remember, that was the PHP CGI executable that was using port 3306. In this case, we've specifically only allowed 3306 to communicate from that tier to the database tier of the application.
All right.
So again, granular segmentation policy has now been pushed.
Got it. I mean, I guess the way to think about this is because we have very unique visibility into the guest and from the application, we're in a position in an automated way to create a tight coupling between the segmentation policy and that application. It's the application driving segmentation as opposed to the network trying to drive segmentation. And by the way, there's other unique visibility. You know, to point out another really great product, there's a product called vRealize Network Insight that also looks across network traffic and can do that not just within our own environment, but across other environments. So there's a variety of things that can contribute to getting this picture. And the point of it is the ability to drive this in an automated way right from the application is very, very, very powerful.
Yep.
So we've locked the network down. And on the compute side, we've pushed those manifests into compute.
Yeah, so one thing to point out is when App Defense first gets pushed into protect mode by default, we push things into alert mode. So think of App Defense as basically being the watchdog now watching behavior, but the remediation that we're taking is only to alert.
So by default, it's detect and alert.
Exactly.
Right, as opposed to active.
And we'll show how we change that in a second. But
okay, all right. So we've now set this all up. Let's switch over to Prajwal. If we could switch on to Prajwal's screen. You getting nervous?
Nope. Let's see. All right. He only made firewall changes, so there are always ports open to communicate outside for any shared services.
Do your worst.
DNS. So I'll start with the step of disabling the endpoint protection on the application server. And I was successfully able to do that on port 53.
Okay, so you're still able to get to the server. Obviously, it has to be open. You're still able to do a reverse TCP shell. You're still able to shut off the endpoint protection.
Yes.
Okay?
And now I'm trying to get shell on the application server.
All right, so getting your shell access onto that server is really going to have you own that server, and then you'll be able to execute other pieces.
All right, still waiting.
I'm looking at DevOps. Are we still live with Santa Clara? We are still live with Santa Clara.
Okay, let's try it again. I mean, there you go.
All right.
Same script, paste.
The beauty of being live.
Yeah.
Okay.
So we have access there, and again, you can see we are on there.
Okay, terrific. You own it.
So I'll try to run the same crypto miner thing using pass the hash attack from the credentials that we harvested in the previous attack.
All right, so we have the credentials. We're going to install the crypto miner on his database, and we can see if this works.
All right, the exploit's trying to run now.
Okay.
And
Trying to connect.
yes.
Trying to connect. I don't know, Prajwal. It's not looking so good.
Looks like it failed.
All right. We failed there. That's not good for you, Prajwal. So you're not making money off crypto miners. What's another way to make money here?
I'm sure it has a database on there. So what I'm going to do is look at the database and see if I can get some nice details.
Steal his data. So you can't own the database, you can't go on and install software on the database, but you can at least query the database. Let's steal data. Okay.
All right, I'm looking at the settings file that Drupal has set up, and I can see the username, password, the host, the port, and the kind of SQL server it's running.
Okay, yeah.
So what I'm going to do is I'm going to do a recon on it and see what tables and data are on there. One table that looked interesting to me is the customers table. And
there you got the customers. Chris, I don't know how good the due diligence was in your firm. You were talking about how successful you are. You got 3 customers, and one of them is you.
The first guy, Tom Corrin, just really has a telephone cord fetish.
All right, yeah, okay. All right. Well, you're not making money off stealing the customer data. How else could you make money here?
I'll go more aggressive on it.
Okay.
Install a ransomware, bring down the site, and demand ransom for it.
All right. By the way, I'm glad it's you doing this, because Alex Toshif, our CISO, would kill me, because if he knew we were using live strains of, we're losing a live strain of Pecha over here.
Yeah. And I think by now the site should be down.
All right. Can we take a look at?
I think we're going to recap the.
All right. Bring it up to my screen, and I'll just recap kind of what just happened. All right. So after the cryptojacking, we set up the firewalls now. So we automated the microsegment. We set up app defense. It's in monitor mode. What you'll see in a second, he was able to connect on and set up a reverse shell. You'll see in a second, the entire attack, app defense is tracking the attack and alerting on the attack, except it's in alert mode. So he was able to get on. He did set up that reverse TCP connection onto it. Again, that will be recognized. You'll see an alert on that stage. He then was able to get shell access and to install the shell. Again, that's setting up an alert, which you'll see in a moment. Where he ran into problems is he tried to move from that over to the database, and the microsegment that's set up is not allowing him to make that connection anymore. So that's why he got lost there. But he can still query it. He can't own it. He can't put software on it. So that's what enabled him to, at that page, to do a query into that database over an open, a legitimately open port 3306. But again, you'll see that caused an alert on both sides, which App Defense is tracking. And then he, again, we didn't have much data on it. So because he had shell access onto that app server, that's what made him install the live strain of Pecha onto that app server and take it out. But let's go over to Chris's screen here.
Yeah, so again,
good.
Yeah, so this
Man,
is my
that's not good.
This is my app server actually being ransomware at the moment. It's almost done.
Bad.
Yeah, so yeah, again, like you were saying, he took advantage of the open ports in the firewall wherever he could. So the microsegmentation policy stopped him from actually getting through the patch the hash attack, but he still was able to use some open ports to execute his attack. And because he had access directly to that machine, he was able to drop malicious executables directly on the machine. Right. So now I'm fully ransomwared out.
That's bad.
Which is not cool.
It's actually part of the attack that scares me the most too. So we have to actually rebuild the Santa Clara system. So you have to let us know when that's rebuilt, because this is the one part that can be.
All right. So what I'm going to do,
I'm going back from a snapshot. So
I'm just going to clean up the environment.
But let's take a look at what App Defense was. We can do that.
Let me clean up the environment first.
Okay.
So I'm just going to revert to the latest snapshot because I want to give Prajwal a fresh environment to attack me in a second.
It's very kind of you.
It is very kind. I'm a kinder business owner.
For the security teams in the audience, that's the way you should be thinking about it when you're defending. You're setting up a clean environment for the attackers to play with.
So the reason why he was able to execute these attacks, right, because the firewall was open, but also because we were only in alert mode in App Defense. So what I'm going to do is, because it takes a minute or two for these to push, I'm going to push these into block mode. So I'm basically going to take our application, our full e-commerce application, and I'm going to now have our remediation be to block these events when he tries to execute them. So if I see something that's out of the normal, I can block. And again, there's a number of remediations that are built into App Defense. Now I'm going to go in and just show you the alarms. And again, these are the alarms.
Let's see what the system was tracking during the attack.
These are the alarms that occurred during his attack as we were in alert phase only, right? So this is essentially his initial request to try to create a reverse TCP shell. This was successful. You can see he was using port 80, port 53, open ports in the network. Here's his PowerShell script that he was running to create this reverse TCP connection out to his machine. So you get full information here about exactly what he was doing and how he was doing it. You can also see every other step in his attack, you know, his attempt to actually do a pass the hash attack, which is the cert utility that he was using to do pass the hash. And then you can also see actually that he's downloaded and installed a full strain of Petra ransomware and ran it on the environment here, right? So again, every step of the attack, because App Defense is in monitor mode, we were alerting and telling you that those things are happening.
Got it. Okay. All right. So you've now set it up. Let's clear those alerts. Okay. And now you've set it up in sort of an active block mode. Are we ready to pass the baton?
I think we might need a couple more seconds.
All right. How are we doing? Because we have to actually rebuild our data center. I don't know if any of you have ever experienced ransomware. You have to clean it up. How are we? We're still a couple of minutes. Okay. So the central theme here is now we have policies tightly coupled with the application that are locking down compute. It can only do, you know, someone tries to mess with the processes, how the processes communicate, any of that. And we have this tight coupling on the firewall.
So I think we're good. So again, this is rules pushed from the cloud down. So, you know, these take some time to propagate through the system. But now that the rules are pushed in the data plane, we should be good to go.
All right. Prajwal, I bet you're sweating now. Let's how do you attack now?
Okay.
So you start by trying to get shell access. That's the first step.
Yes, and I get an error saying the exploit failed.
Yeah.
So looks like I would see it has an endpoint protection, so I'll try to disable
that.
Let's
try to disable whatever it's blocking it.
Yeah, and that failed as well. So.
Okay. All right. Let's bring up my slides for a second, just so we can understand what just happened here, right? So now that things are locked, both on the compute and on the network, while these ports have to be open for the legitimate functioning of this application, even just executing this, it doesn't match what the application was intending to do. And that's the key thing. I mean, we've had the concept in fraud as well, right? The concept in fraud is at some point the fraudster is not paying your mortgage. At some point, the attacker is not doing what your application intended to do. And that's really the power here. The other thing that was very powerful is it's not so easy to turn this off, ultimately, because we can leverage the hypervisor to protect our position. So this is very, very powerful. And ultimately, it's a very, very difficult. It was a much, much tinier attack surface now. Very effective on ransomware, very effective on lots of most forms of malware, very effective on lateral movement, command and control on that. Okay, so we have now protected. Are we going back on to your screen? Can we switch on to Chris?
Just to show you, again, he attempted the exact same behavior. So in this case, it was PowerShell trying to attempt the exact same behavior of invoking a reverse TCP shell. In this case, because we were in block mode, we stopped it right from the start. So his attack was, pretty unsuccessful right from the beginning. So in that case, the full thing was completely unsuccessful.
All right. Okay. So we've taken care of the data center, but let's think about what we have to do for our users, right? On the user side, the really concern is that's a very big attack surface, all of these user machines out there. And for that, I would like to bring up the Vice President of End User Services of Chords. Andrew, please join us on stage. Andrew, welcome. Nice to see you. Andrew's actually day job. Andrew runs product management on a lot of our end user Workspace ONE stuff. So you're going to show us Workspace ONE intelligence and the concept here.
Yes, so let's talk about the end user devices. We saw some great capabilities around protecting your data center. Within Workspace ONE, we can provide great user experience while enforcing enterprise security. With Workspace ONE intelligence, great data around applications, devices, identity, to build that holistic view of a user and force that zero trust model. In addition, we've partnered with leading security vendors in the ecosystem. In this case, we see that a ransomware attack has been detected by Carbon Black, and they've notified us. So what we're going to do is we're going to go ahead and view reports that I've created. Luckily, I've strengthened the environment by creating not only these visualizations, but I've actually created some automation. So let's go see how I've protected my environment. So I'm now viewing a list of compromised devices here, and I see that this ransomware has actually been impacting some of my domain administrators. That's not good. Again, luckily, I've fully automated my remediation to an event like this occurring. So I'm going to go over here to automation. Now, when I talk about automation, think about workflow orchestration. Think about all this data we're collecting, being able to trigger on changes in that data set to enforce a set of actions. These actions can be security related. They could also be related to improving end user productivity, replacing failing devices, or pushing out applications when they're needed, pushing out patches. In this case, let's take a look at how I'm protecting against this ransomware attack. So we cover both desktops, mobile devices, ruggedized devices, a variety of platforms. We can also take advantage of those specific platforms and the capabilities there, so you'll see some of that here. In this case, we're looking at Windows devices that are domain administrators where they've been attacked. So the first thing we're going to do is we're going to actually call back into the data center. We're going to turn up the dial. We're going to raise the security level in the data center to prevent the spread of this ransomware from those end users' devices back into that data center. We're also going to update our controlled folder access policy, which means we're going to move our critical files to read-only mode so they can't be encrypted by that ransomware. We'll create a ticket in ServiceNow for tracking by the organization. We'll also enforce this at the network layer, so we'll add these device endpoints into a quarantine group as part of NSX. We're also going to notify the end users about all these everything that's going on with their machine.
So you're in a really unique position to be able to understand both a user perspective and a user device perspective. You have the ability to take in your own intelligence and analytics from other sources, other security partners. And then automate responses, including, in this case, automate and tell the data center, in this case App Defense, to elevate the threat level and change the security posture in the data center.
That's right.
All right, terrific. Thank you,
Thanks.
Andrew. So appreciate it. So, Chris, we'll go back to, not to your email, but to App Defense. And walk us through what Andrew did and how that connects back into App Defense.
Yeah, basically what he did is he sort of adjusted the remediation actions for the scope, the domain controller scopes. Remember, in App Defense, you can basically segment off different application types into what we call security scopes. Those security scopes have their own sets of behaviors, they have their own sets of rules, they have their own sets of remediations. In this case, he took the domain controller scope and he actually moved the remediations from alert only into a full blocking state. So it becomes a dynamic way of controlling policy.
Got it. So the idea of what we're really trying to build here is sort of a DEF CON type of utility to be able to say you can go into a different sort of threat level and we could ratchet up how aggressive we're going to be in terms of how we remediate or how automated the remediation would be. So what are we doing next?
All right, so we're going to show the adaptive segmentation portion, at least the change portion of the adaptive segmentation.
Okay, so this is very key. What we've done so far is like learn and lock, and the last piece is adapt. The issue here is applications change all the time. One of the reasons people hold back from doing zero trust models or very least privilege models is the stuff changes and then it becomes very brittle. And so the idea is, look, the stuff may have changed, I may not have seen it when I've learned the system. So this is about the adaptability.
Yeah, so I'm going to highlight something here. LSASS is a common Windows executable. It does a lot of authentication-based processes for Windows. In this case, what we've learned in the profile and what we verified in the profile is I'm expecting inbound connections, right, on these sets of ports.
Yep.
Now that's the only thing that really is currently being approved by the app defense system in order to run. So sometimes deviations happen, deviations occur, whether it's upgrades of software, whether it's new behavior that hasn't been learned. That's always the vein of the people's existence, is how do I deal with change, operational change. So in this case, what I'm going to do is I'm going to kick off an event for LSASS that is outside the range of this behavior.
Yep.
So I'm actually going to generate some outbound network traffic from from LSASS on port 389. I'm just going to run a quick script to do that.
So this is going to be a behavior. It's actually legitimate for LSASS.
Yep. So I've kicked that behavior off, right? And essentially now, App Defense is going to recognize that as an alert. So it's going to look at that and say, this is violating what is normal expected.
It wasn't in the manifest.
It wasn't in the manifest. Now, the critical thing is, what does it do with that information as it reaches the App Defense Management Console?
Yep.
In this case, what we have done is we've taken that event, we've classified it, so we put it through our classification engine. We've looked at it in terms of the behavior that we expect to see across the population.
Yep.
And we've actually verified that this is trusted behavior. Not just that it's an executable that's trusted, but the behavior specifically, communicating on port TCP, outbound on our protocol TCP, outbound on port 389, that is trusted behavior.
So it's not normal for you, but we've looked at thousands of other customers, this is normal.
Exactly. So now what we've done is we actually automatically added this behavior into the expected state manifest. We've now taken our expected rules, both on the compute side and the network side, which I'll show in a second, and we've now auto-adjusted the behaviors that we expect to see. So I'll just bring up LSASS again. Apologize, it takes me a second to find it with all the stuff that runs.
Okay, so this should update the compute manifest, so that changes how compute is locked down, and it should update on the firewall rules itself.
Yeah, I clicked on the wrong thing for a second, hold on. So just clicking into LSASS, now we see that we have outbound connection activity that is allowed across port 389.
Okay, great.
Which is great. That's exactly what we want to see. And then going into NSX, what I'm going to do is just refresh the NSX firewalling rules. And again, we want to be able to adapt our control policy across the board. We've approved this behavior. We now have a new adaptive segmentation policy set. This is a new section inside the NSX firewall. If I edit or just show you what specifically we're allowing here, we've now allowed port 389 to be communicated with on the firewall as well.
So there you have it, adaptive microsegmentation, right? The ability to really adapt as the app, tie it to the application and change it as the application changes.
Yep.
Terrific. Well, thank you. Prajwal, Chris, thank you so much.
My pleasure.
It's really it's incredible. And to the DevOps teams monitoring Santa Clara, thank you. Can we switch to to my slides for a moment? Okay, look, that was, as we saw over here, the system going out, seeing a new thing, the machine learning kicks in, says, I've seen this kind of behavior commonly across a population of tenants of customers. That adjusts the manifest, creates the firewall rule, and that's the idea behind this adaptive portion. In all of these cases, it's about us leveraging our infrastructure to be able to understand and get clarity on the applications and data at the compute, at the network, at the user level. And these are some of the security products, but it's also some incredible management products that layer, as I mentioned, vRealize Network Insight, and other products that help gain visibility here. And it's the ability for us to work with an ecosystem, with strategic partners across an ecosystem, players like Carbon Black and Palo Alto Networks and IBM and SecureWorks, to enable them to benefit from this, to deliver really effective solutions on top of it, and take this massive complexity really and start to say, listen, we don't need more security products, we need more security. We need a handful of things that can get the job done and really have a meaningful impact on this. We're trying to do this not just within the data center as we showed you, but really in an end-to-end fashion. from the public cloud to the private cloud, from the container to the VM, from really to the user and to the edge, and really provide, in this case, a security fabric to have an architecture that is architected in as opposed to bolted on. Now, there's a lot of places to learn more here at VMworld. There's a couple of sessions. There's a session, fantastic session that goes deep onto the machine learning later on Wednesday, led by Vijay Ganti, who you saw in Pat's keynote. He leads the machine learning team. We have a whole section on containerized applications, as we've been, NSX has done work in containers, App Defense as well. We've done some work with a very innovative company called Aqua Security, and we're going to go deeper into some of those concepts there. There's a bunch of other sessions, as I've listed here, including this least privilege session. There's a bunch of resources to learn more, both in the demo. There's some education and training courses that folks can take. There's hands-on labs. And then there's a bunch of material both in vMugs, connecting with peers, and we're actually going to be publishing this video, I believe, tomorrow. So if folks at home, you want to see it again and you want to share it with folks in the office, that you can take a closer look at this. We really want to make this accessible for everyone. Now, the Bitcoin that was mined earlier has been sent out into the ether. This is my Oprah Winfrey moment. Hidden under some of your seats, there's one grand prize, and that grand prize is actually dinner at Craft Steak. We're actually doing a special dinner tonight with the NSX team. So in someone's seat, there's a cranberry candle under each of your seats. So there's that, and then in some of the seats, there's also these puzzles, these new puzzles that were created by the vSphere team. But we also have some other materials that you're welcome to come join us with afterwards. But again, I hope that was helpful. I hope that was insightful to what we do. A special thank you to, there was an incredible amount of engineering that went in to designing that live application. So thank you to the whole engineering team on that. Thank you, everybody. Enjoy the